Hey everybody, it's Wilman here. I'm just going to do a quick video to talk about one of our last things in our quadratic unit for Algebra 1. So let's get started. So kind of reviewing from the past couple weeks, what we were told to do was to factor these quadratics or polynomials. And what we meant by factor was basically find the zeros, or basically find the numbers that x can be in order to make this equation equal to 0, okay? So one of our best techniques we have is to do this. I think the last video I made dealt with doing this. You would take your a value times your c, so you would take 1 times 12, and you would get 12. And then I would have you find what two numbers can multiply to 12, but add to a 7. And what you'll notice, two numbers that multiply to 12, but add to 7, are a 3 and a 4, both positive. So I can take my starting quadratic, x squared plus 7x plus 12 equals 0, and actually rewrite it as this. X plus 4 times x plus 3 equals 0. And again, why do I want to do this? Because based on how it's written, I could tell you right away what x has to be to make each one of these binomials equal 0. What does x have to equal there? Negative 4. Because negative 4 plus 4 would be 0. 0 times anything is 0. What would x have to equal here to make the whole thing equal 0? Negative 3. So we're really good at just taking the a times the c and going from there using our patterns, okay? But you are going to encounter problems like example 2. X squared plus 5x plus 2 equals 0, okay? So let's say you didn't notice it was any different. Let's go through our normal steps, our normal thinking, to see if we could solve it that way. So a times c would equal, let's see, 1 times 2 is 2, okay? What are two numbers that multiply to 2 that are not decimals, but they're going to add to a 5? And what you're quickly going to notice is the only two numbers that will multiply to 2 that are not decimals are 1 and 2. But 1 plus 2 equals 3, not 5. So we encountered a problem. Here is where we are going to introduce one of the most useful things for solving quadratics, okay? So starting with this, I'm going to circle it in orange. We know that all quadratics can take this form, ax squared plus bx plus c equals 0, okay? Some of these letters, a, b, or c, could be equal to 0, but they all take this general form. We have something called the quadratic formula, which can be used to solve any quadratic equation that you are given. Anytime you have something like what we have in question 1 or question 2, you can automatically use the quadratic formula to get your answers right away, instead of using one of our previously learned techniques. The reason why we started with the other techniques is because those will be quicker in a lot of cases. But again, we're talking about the quadratic formula because our shortcuts do not always work. The quadratic formula should always be a good backup plan. So here's what you do in the quadratic formula. If we had more time, we would talk about how we found this formula, but for today, we're just going to focus on the physical formula. So to find your x values, you're going to take negative your b value plus minus. I'll talk about what that means when we get to an example. Square root of b squared minus 4 times a times c, and then we're going to divide that whole entire thing by 2 times a, okay? So this would be a very important thing to write down somewhere. Write down in your notebook, pause the video, write it on a sheet of paper, because we're going to use this all throughout the video. So going back to our question Question number 2. Let's use the quadratic formula to find what x could be to make this equation true. So x equals negative b. My b value is positive 5, the number positive 5. So I need to write negative b, negative 5, plus minus square root b squared. So 5 squared minus 4 times my a value. My a value is in front of the x squared. It's just a 1. And my c value is the constant at the end, the positive 2. Okay? That's all under a square root. And then we divide that whole thing by 2 times a. And again, our a was 1. So, again, we're not substituting in the variables like the x's. We're substituting in the coefficients, the numbers in front of the x. So once you get the formula down, all you have to do is look at what you're given and just put them in the right spot in the formula. So we have negative 5 plus minus. Let's clean up the square root. So 5 squared is 25 minus, let's see, 4 times 1 times 2 is 8. Okay. And then on the bottom, we got 2 times 1, which is 2. Okay. Let's keep going. Negative 5 plus or minus square root of 17 over 2. Okay. So I'm going to do this as my next step. Some other teachers might say something different, but this is what I'm going to do. I'm going to look at what the square root of 17 is as a number. So I would type in the square root of 17 into a calculator. Let's see. Square root of 17 is about 4.12. So instead of square root of 17, I'm going to write 4.12 over 2. Okay. Now you're probably wondering, Mr. Willman, what does the plus minus mean? That basically means you need to consider 2 cases. You need to consider when that plus minus is just a plus sign, and you need to consider it when it's just a negative sign. That is how we're going to get our 2 answers for x. And why should we get 2 answers? Because it's a quadratic. Most quadratics will have 2 answers. Some will have 1, some will have 0, but most will have 2. So case number 1, let's pretend that this plus minus sign is a plus. I'm going to rewrite what you see except with a plus sign. So minus 5 plus 4.12 over 2. And feel free to use your calculator. So negative 5 plus 4.12 is, I believe it's negative 0.88. Yep. And negative 0.88 divided by 2 is negative 0.44. So x could be negative 0.44 to make the equation 0, okay? Or case number 2, let's assume that plus minus is actually a minus this time. So 4.12 over 2. And again, let's calculate that. So negative 5 minus 4.12 is 9.12. 9.12 divided by 2, negative 4.56. So here's what we just found. If you would take either one of these answers and put them in to the quadratic in question 2, you would find that you would get 0 equals 0, which is exactly what you want. You want to find what x has to be in order to make that left side of the equation 0. And the 2 possibilities are negative 0.44 and negative 4.56, rounded. So We're going to do a couple more practice problems with the quadratic formula. I'm going to erase question 1. I'll leave question 2 for now. Okay. Here we go. Let's try this one. Let's do x squared minus 4x equals 12. Okay? So we could use the quadratic formula for this one. We could actually use another technique and get the same answer, but let's practice using the quadratic formula since that's what we're talking about. So before you try to use the quadratic formula, remember, we want to have it in this form. We want to have the a, the b, and the c. We want to have every number and term on one side together. Notice, we do not have everything to one side. We have a 12 on one side and 2 terms on the other side. So the first thing you have to do is move that 12 to the other side, leaving you with x squared minus 4x minus 12. If you do not move this term to the same side as the other terms, you are going to get the wrong answer using the formula, okay? All right, so let's use the quadratic formula. X is going to equal negative b, so negative version of negative 4 plus or minus the square root b squared, so negative 4 squared, minus 4 times a, which was the 1 in front of x squared, times c. C is that minus 12, all over 2 times a again, which was 1. Okay, so once you have it set up from here, if you take your time, you should get to the right answer. So negative times negative 4 would be a plus 4 on the outside, plus or minus. Negative 4 squared is 16. Negative 4 times 1 is negative 4. Negative 4 times 12 is, negative 4 times negative 12 is plus 48. And on the bottom, 2 times 1 is 2. Okay? So 16 plus 48 is 64 over 2. The square root of 64 is 8. And then now we can consider our 2 cases. 4 plus 8 divided by 2. Or we could do 4 minus 8 over 2. So if we look at the red case, 4 plus 8 is 12. 12 divided by 2 is 6. So x could be 6. Or on the right, 4 minus 8 is negative 4. Negative 4 divided by 2 is negative 2. So if you put a 6 or a negative 2 in for x right here, your equation is going to be true. Your equation will work out, okay? Those are the zeros of the quadratic. So quadratic formula, make sure everything gets to the same side before you use it. Otherwise, you're not going to get to the correct answer, okay? Also, if you have to round, I would recommend rounding to the nearest tenth, okay? You don't want to have too many decimal places, but you also do not want to have too few. You kind of want to have the in-between amount. I'm going to talk about one more very quick thing, and I'm not even going to do an example with it. I think you guys will understand it and kind of remember it. We've touched on it in class. Let's say that you had a problem and you were using the quadratic formula and you got down to something like this. Let's say you got down to the point of 6 plus or minus 10 minus 40 over 10. Okay. I made up these numbers, but I'm going to make a very important point. If you would clean up this square root of 10 minus 40, you're going to get this. 6 plus or minus negative 30, okay, over 10. But there's a problem. If you try to type in the square root of negative 30 into a calculator, it's going to say no, solution, not possible. Why can you not do the square root of a negative 30? Well, if you remember, the square root is basically asking you what number times itself gives you the number underneath. So, what number times itself will give you a negative 30? Let's see, you can either take a positive times a positive and you'll get positive. You could take a negative times negative and you'll get positive. The only way we can get a negative 30 would be if we took a positive times a negative. But is a positive 2 the same as a negative 2? No. One is positive, one is negative. They are not the exact same. Therefore, if you have a negative number underneath the square root when using the quadratic formula, that is not possible. So your answer to the quadratic would be no solution. There are going to be no numbers that x can be to make your equation equal 0, make your equation true. There are going to be a couple like that on the homework, but if you guys remember this simple little trick, I think you'll be okay. So to kind of recap, we learned about the quadratic formula, which is still written here on the top. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, okay? And before you use the quadratic formula, you need to get the a, the b, and the c. You need to get all terms to the same side of the equation, okay? There are also going to be examples where you may not be given a b or a c. It might just be a 0. That is okay. The only time you're going to run into a problem is if there is a negative underneath the square root as your final number. That's the only time you're going to run into a problem, okay? So that's going to wrap up the quadratic formula video. We have a list of problems from the textbook on our website that you guys can work on. There's also an answer key that you can check your answers with. And as always, let us know if you have any questions along the way. Thanks for watching, guys. See you later.